friends, now we are in the 8th class of signal and system basics. So here the 38th problem is a system with input xt and output yt is defined by the input output relation yt equal to integral minus infinity to minus 2t, okay, x tau d tau. So the system will be causal. There are 4 alternatives given, and this question has been asked in GATE 2008. So in all the alternatives, it is the question is asking about causality, time invariance, and stability. So let us check whether the system is causal, time invariant, and stable or not. So let me first check about causality. So check for causality. Okay, check for causality. So now we can clearly see that yt is equal to yt is given that yt is equal to minus infinity to minus 2t. Okay, minus 2t x tau d tau, x tau d tau. Okay, so it is given. So we can clearly see that yt is varying from varying from minus the value of x tau. Yt is the integral of the value of x tau from minus infinity to minus 2t. Okay, so but if we take, suppose if we take the value of t as suppose minus something, minus 2. So if we take the value of t as minus 2, so if we take t equal to minus 2, then what will happen? Then y minus 2, that will be equal to minus infinity to this limit will be, the upper limit of integral will be how much? Minus 2t means 4. Okay, x tau d tau. Now let us see. Y minus 2 is depending upon the input from minus infinity to 4. Okay, it is the integral of input x tau xt is the input and yt is the output. Okay, so the output is depending upon the input from minus infinity to 4. So for t equal to minus 2, for the time from after minus 2 onwards, that is minus 2 to 4 is future. So the output is depending upon future, and that's why the system is not causal, because the output is depending upon the future. So we can write here the system is not causal. The system is not causal. Non-causal, or you can say. Okay. Now let us check for time invariance. Okay. So check for time invariance of the system. Check for time invariance. Time invariance. So it is given that yt equal to, so it is given that here yt is equal to nothing but minus infinity to minus 2t, okay, x tau d tau. Okay. Now if we find the delayed output by time delay capital T, then it will be, we can write here y t minus capital T. Okay, this will be nothing but minus infinity to, it will be minus 2 t minus capital T. Okay, the upper limit will change and rest all will be same. Okay. Now suppose we delay the input by t second, So what will be the output? So output when the input is delayed by t second. So let me write that y t comma t, and this is nothing but this is the output of the system when the input is delayed by t second. Okay, capital T second. So this is nothing but this is the output of the system. This is the output of the system when this is the delayed output. This is the delayed. This is the actual output. Okay, this is the actual delayed output. Okay, and this is the output of the system. Okay, when the input is delayed. Okay, so let me denote it by y t comma tau. Okay, so it will be nothing but it will be minus infinity, and this will be minus 2t. Now what will change? X here, x tau minus t, it will be x tau minus capital T d tau, because we are delaying the input. Okay, now we can clearly see that both are not equal. Okay, y t comma tau, this is the output of the system when input is delayed, and this is the delayed output of the system. Okay, so both are not same. So now we can say that the system is time variant, or the system is not time invariant. Okay, so hence we can write here y t minus t is not equal to, okay, y t comma tau, t comma t. Hence the system is time variant. Time variant. Okay. Now we are left with one check, that is about stability of the system. So let me write here. Check for stability. Okay. Check for stability. Now since yt is equal to yt is minus infinity to minus 2t. Okay, x tau d tau. So here it is given that yt is a infinite integral. One side of integral is infinite. So even if we take the x tau is bounded, then it is a fair possibility of getting yt unbounded. Okay, because if we add some bounded thing up to infinite time, then it will become unbounded. So now we can clearly see that the system will not be stable. Okay, so the system will be unstable. So here the system will unstable. Unstable. Now let us see which of the given options is correct. So the system will be non-causal, time variant and unstable. So non-causal, time variant and unstable. So option number D is the correct one. Okay. The next question is a signal xt equal to sine sinc. This is called sinc function. Sinc alpha t, where alpha is real constant and sinc is defined as sinc cx equal to sin pi x divided by pi x. Okay, is the input to a linear time invariant system whose impulse response st is equal to impulse response of the system is given. This is st equal to sinc beta t. Okay, where beta is a real constant. Okay, if minimum alpha t denotes the minimum value of alpha and beta, and similarly maximum alpha beta denotes the maximum of alpha and beta, and k is a constant. Okay, which one of the following statement is true about the output of the system? So there are 4 statements given, and this question has been asked in GATE 2008. So let us see which statement is true. So it is given that, as we know from Fourier transform, that sinc alpha t, the Fourier transform of sinc alpha t, is a rectangular pulse. Okay, so it is a rectangular pulse of magnitude 1 by alpha, and varying between minus alpha by 2 to plus alpha by 2. Okay, so let us write here, suppose the Fourier transform of sinc alpha t is given by, let us write here sinc alpha t. Okay, the function is ft. Suppose ft is sinc alpha t. Okay, and now we are applying here Fourier transform. So let me write here ft. So this we are applying Fourier transform, and after applying Fourier transform, we will get the function like suppose this is xt, then it will be better, because then we get the Fourier transform as xn. So if we denote it in frequency domain, so it will be like xx will be like this only. The magnitude will be, this is frequency, okay, and this is this xf magnitude. So this magnitude, this will be how much? This will be 1 by alpha. Okay, this will be 1 by alpha, and this will vary from, it will vary from minus alpha by 2 to plus alpha by 2. Okay, so xf will be a rectangular pulse of width alpha varying from minus alpha by 2 to plus alpha by 2, and of magnitude 1 by alpha. Okay, so it is given here that the input to a linear time invariant system whose impulse response is also given. Impulse response is st equal to sinc c beta t. Okay, and the input is here again it is written that the signal here, let me highlight it, the signal xt equal to this, xt equal to sinc alpha t, where alpha is a real constant, is the input where alpha is a real constant, and sinc cx equal to sin pi x divided by pi x is the input of a linear time invariant system whose impulse response st equal to sinc c beta t. Okay, so this is the input. Okay, this is the input, it is written, this is the input. Okay, so this input is applied to a system whose impulse response st is sin sinc beta t. Okay, so it is given that the input is, so let me write here, given that input, so let me write input, this input is sinc xt, and this is nothing but sinc alpha t. So xt equal to sinc alpha t, it is written like that. So input is given, and I have also calculated, I have also represented it in frequency domain, the Fourier transform, and it is also given that the impulse response of the system, okay. So also given that impulse response impulse response of the system. Okay, so impulse response of the system, it is given that how much it is st equal to, this is st equal to sinc c beta t. Okay, now it is given. So if we take its Fourier transform also, then it will become hf. So Fourier transform of impulse response will be the Fourier transform of impulse response ht will be hf as below. Okay, so if we represent it in frequency domain, so it will be nothing but it will be like this. So it will be hf. Okay, and this will be frequency f, and again here it will be 1 by beta. Okay, so let me write it by red so that it would be visible. So it would be, this point would be 1 by beta, here minus beta by 2, here beta by 2. Okay, so this would be the Fourier transform of impulse response st. Now the output yt, here it is written that output is not written, so let me write output yt will be nothing but it will be the convolution of impulse response st and the input xt. So let me write here, let me make some space here so that we can write. Okay, now the output yt will be yt equal to xt convolution ht. Okay, now if we take the Fourier transform of both sides, then this will become yf, and yf will be equal to nothing but xf multiplication hf. This convolution will get converted into multiplication itself. Okay, so if we take Fourier transform both sides, then yf, so yf is, what is yf? Yf is a Fourier transform of yt. So yf equal to xf multiplied by hf. Okay, now the graph of xf and hf both are given, and if we multiply these two terms, then we will get the graph as the magnitude as 1 by alpha into 1 by beta. So magnitude will be 1 by alpha beta, and this graph will vary between between either minus alpha by 2 to alpha by 2 or minus beta by 2 to beta by 2, and that will depend upon, and that will only depend upon the which one is less. If alpha is less, then it will vary between minus alpha by 2 to alpha by 2. If beta is less, then it will vary between minus beta by 2 to plus beta by 2. Okay, so we can write here the graph will be like here, the graph of yf, this is nothing but the graph of yf. Okay, so this is nothing but the graph of yf. Okay, so graph of yf will be like this. Okay, so this is, suppose this is k. Okay, so suppose this is k, so k will be nothing but 1 by alpha beta. Okay, and this will be minimum of alpha by 2 and beta by 2. So this point will be minimum of which alpha by minimum of minus alpha by 2 here it will be since it is minus alpha by 2 and this is minus beta by 2. So here it will be we can say minus minimum. Okay, so this will be minus minimum of alpha by 2 beta by 2. Okay, similarly here also we can write it will be minimum of alpha by 2 and beta by 2. Okay, I think it is clear to all of you. So now this will be the Fourier transform of YF. So if we take the inverse Fourier transform of YF, then how much it will come? So it will come. So if we take the inverse Fourier transform, so it will come. So it will be here. Let me see which of it will be of the form K sinc alpha sinc C gamma T. So, again it is written that where gamma is minimum of alpha and beta. Okay, it will be of the form K sinc gamma T, where gamma is alpha maximum alpha beta. Okay, so here we can clearly see it is minimum of alpha beta. Okay, and so we can write here it is defined that sinc Cx is nothing but sin pi x by pi x. So here if we take the inverse transform, so if we take here the inverse transform, so let me write here not k, let me denote it by 1 by alpha beta. Okay, so this will be 1 by alpha beta. Okay, so now if we take the inverse Fourier transform from here, so yt will be nothing but some constant k, and what will be the function? The function will be sinc C, again here sinc C gamma T. Okay, and gamma will be minimum of alpha and beta, because here it is varying between minimum of alpha by 2 and beta by minus alpha by 2 and beta by 2 to alpha by 2 and beta by 2. So it will be where, let me write here, where gamma is minimum of, so where gamma will be minimum of alpha and beta, comma beta. Okay, now it is, and the value of k, we can calculate the value of k, because the value of k will be since its magnitude is 1 by alpha beta, so the value of k that will depend upon whatever value, whatever is the minimum value of alpha and beta. So it will be of the form this. So option number A itself is correct, because let us see other options. It will be of the form k sin gamma T, where gamma is maximum. This is not correct because it is minimum of alpha and beta. It will be of the form k sinc C alpha T. Now we cannot say like that. We have to check whether alpha is where which one of the alpha and beta is minimum. It cannot be sinc type function. No, it will be sinc type function because it is a rectangular pulse of magnitude of 1 by alpha beta. So the option number A is correct. The next question is, the transfer function of a linear time invariant system is given as gs equal to 1 by s square plus 3s plus 2. Okay, the steady state value of the output of this system for a unit impulse input applied at time instant t equal to 1 will be. There are 4 options given, and this question has been asked in GATE 2008. Okay, so the transfer function is given as gs equal to, so it is the transfer function is given as gs equal to 1 by s square plus 3s plus 2. Okay. Again, a input is applied. Here it is given that a input is applied, a unit impulse input is applied at time instant t equal to 1. Okay. So here the impulse input is a delayed impulse input because it is applied at time t equal to 1. So if we write the impulse input, if we denote the impulse input by delta t, then this impulse input will be denoted by delta t minus 1 because it is applied at t equal to 1. Okay. So the input is here, input is nothing but delta t minus 1. Okay. So what will be the output? If we take the output as Ct, then the Laplace transform of output will be nothing but, let me write the Laplace transform of input. Let me write it as xt input as xt equal to delta t minus 1. Okay. Now the Laplace transform of xt will be xs. So if we take the Laplace transform of xt will be how much? Xs. This will be xs equal to e to the power minus s, only e to the power minus s, because the Laplace transform for delta t, that is impulse function, is equal to 1. Okay. But here since it is a delayed impulse function, that's why due to unit delay, means due to delay of minus 1 second, it will be e to the power minus s. Okay. Now the Laplace transform of output will be, let us take the output as Cs. Okay. So the Laplace transform of output will be Cs equal to nothing but Gs multiplied by Xs. Okay. So what is Gs? Gs is given 1 by s square plus 3s plus 2, and Xs is also given, it is e to the power minus s. So it will be nothing but e to the power minus s divided by s square plus 3s plus 2. And the question is asking about the steady state value of the output. Okay. So a steady state value means final value. So here we have to apply the final value theorem due to Laplace for getting the steady state value. So the steady state value of Cs will be the steady state value of Cs will be, or we can say output will be CSS. Output means C is output C as steady state, and that will be nothing but limit t tends to infinity. Okay, Ct, and that will be if we apply the final value theorem due to Laplace, then it will be limit s tends to 0 SCS. Okay, and this will be limit s tends to 0 s multiplied by e to the power minus s divided by s square plus 3s plus 2. Okay. So now if we put s equal to 0, then this term will e to the power minus s will become e to the power 0, and that will become 1, and in denominator it will these two terms will become 0, and only 2 will be left in denominator. And so, but since s is multiplied in numerator, so numerator will be 0 and denominator will be 2 itself. Okay, so it will be 0 by 2, so it will be 0. Okay, so which one of the given option is correct? So option number A is correct one. Okay. At the last of the lecture, I would like to share one of the most important thing to you people, that if you like my video, then you must subscribe the video, so that there is no need to search the new video which I upload. The automatic upload will come to you. What you have to do for this? It is very simple. There is a circular logo containing my photo is coming in right of me. You have to just click on that for subscription.